Hi everyone, in this video we'll be talking about how to graph a derivative. So in the previous video where I talked about what is a derivative, I showed you me graphing different derivatives for you to understand how derivative works, but I never really explained how to graph the derivatives. And so in this video we'll be talking about what signs and criteria you can use to help you graph a derivative. So the first thing you need to know is that when f of x is increasing, f prime of x is positive, greater than 0. So this makes sense, right? When this is f of x. When f of x is increasing, that means its slope is positive. And if the slope is positive, then that means f prime of x, which is the slope, has to be positive as well. And it's the same thing if it's decreasing. If it's decreasing, then it's negative. Okay, second one. If f prime of x is going from negative to positive, then that is a relative minimum on f of x. So if f prime of x, so if our function is, the slope is going from negative slope to positive slope, negative slope to positive slope, then that point will be a relative minimum. And same thing if it's the other way. If it's going from positive to negative, then it will be maximum, relative maximum. If it's going from, if the slope is going from positive to negative, then at that point it's going to be a relative maximum for f of x. So if f of x is going, let's say, from here to here, then at this point it's going from positive to negative. So at this point in the normal graph, it will look like positive to negative maximum. So it will look like something like this, and that point corresponds to this point. Okay, so this is a derivative graph, f of x, f prime of x, and this is the normal graph, f of x. It goes from positive to negative, and so we have a relative maximum. Okay, third one states that f prime of x minimum, relative min or max is equal to a point of inflection on f of x. So now we're looking at the f prime of x min or max. So if this graph is f prime of x, and we have a maximum here, then this point will correspond to a point of inflection. What is the point of inflection? It is like when we have, let me think, when something like this, it's this point. It's the point where the slope is the slope is the steepest. All right, so which makes sense over here because we have a relative maximum here. So it's positive to negative. No, okay, so the slope is from increasing to decreasing. So this is the relative maximum, and so we have point of inflection here, and there's also another point of inflection here. This point. So if our slope is going from the most positive to less positive, then this point of inflection will actually correspond to this one, because this is an increasing slope, like what we have here, to the point of inflection, and then the slope starts to decreasing, and it starts here. So f prime's min or max is equal to the point of inflection on f of x. So right now you can just write off these down, and as you start doing more practice, all of these will start making sense. So next one we have, if f double prime of x is equal to 0, that is the same thing. That is also equal to a point of inflection. By the way, this says f double prime. It's also a point of inflection on f of x. And that makes complete sense. Why? Because over here, look at that. If this is f prime of x, if this graph is f prime of x, then at this line, okay, it shouldn't be sharp, right? It shouldn't be sharp. I should draw a round edge. But let's assume this is round, right? Then at this point, as we learned earlier, because this is the min or max, then the derivative of this has to be equal to 0. And if the derivative is equal to 0, then it's the same point. It's a point of inflection. And finally, if f prime of 0 then and if, alright, if f prime of 0 and if f double prime, the derivative of that point is positive, then the point at that point is a relative, let's see, positive. If it is positive, then it is if f double prime is positive, let me think. Okay, so if f double prime is positive, it will be this. So it will be relative minimum. So if f prime of x is 0, meaning a point like this, right? If f prime of x is 0, and f double prime of x is greater than 0, so this is a greater than sign. This is greater than sign. And if f prime double prime of x is greater than 0, then that point is a relative minimum. Else if f double prime of x is less than 0, then it is a relative maximum. And how you can remember this? Less than 0 means down, and this is a concave down. This is called concave down. Greater than 0 means up, and this is a concave up. Alright, and that's how you can remember if, okay, that's how you can remember these two. And this can only apply if f of prime of x is 0. And anything, and f prime of x is 0, we call this a critical point. Critical point. Critical point. Critical point is when f prime of x equals 0 or infinity. Is it called a critical point? So if f prime of x is a critical point, and then you decide whether it's a relative min or max. So, oh wait, no, it's not a relative min or max. It's just concave upwards or concave downwards. It's not relative min. Not relative min, relative max. It's just simply telling you it's concave upwards or concave downwards. So if at this point, if f prime of x is known to be 0, then f double prime x greater than 0, concave up. If less than 0, concave down. F double prime x less than 0, concave down. So that's all the rules there are. So let's take a look at a practice problem. Let's go all the way down. Okay. So we have this. Let's take a look at this, right? So this graph is f of x. First, let's find the relative min and max. All right. So we have this point, this point, this point. At these 3 points, the derivative will be equal to 0. So that really helps a lot. So -5, 0, and 5 will have derivative of 0. -5. If this is f prime of x, -5, 0, 0, 0, 5, 0. So this can be it. -5, 0, 0, 0. So this can be it. So C and A are already eliminated because they need 3 zeros. All right. So now let's take a look at this. We know that this is a point of inflection. So at these 2 points, it must be a relative min or max. And this point of inflection is going from a very negative slope to a less negative slope. So it's going to be negative to less negative. So negative to less negative. So at this point, we already know it's D. But let's continue. Actually, no, there's nothing else to do, really. You just know that this is going from more negative to less negative. And let's see, if at this point is equal to 0, f double prime, we can draw the f double prime if we want. This is f prime of x. This is f, let's try to draw f double prime of x, alright? So we know that when f prime of x is f prime of x, let me see, this will be just the same thing, we just take the derivative of this. Actually, no, there's no point of doing the derivative of this, will just be very negative until a certain point, which we call this point 0, very negative until a certain point, and then less negative, and then it becomes positive, actually. Positive to a certain point, and it becomes negative. So yeah, so there's no point of doing f prime of x. So yeah, that's just an example of how to use clues from f of x to draw graphs on f prime of x and f double prime of x. So yep, these are all the rules that you need to know. And knowing these is important because we'll be working with these when we start talking about PVA. Alright, that's it. Thank you for watching.